Welcome back everyone to this lecture on Spacy Basics. There are a few key steps for working with Spacy that we're going to cover in this lecture. The first step is loading the language library. Remember, you need to have installed the language library as shown in the Spacy setup lecture. Then, once we've loaded in that language library, we build a pipeline object, and from that pipeline object we can use tokens, perform parts of speech tagging, and understand different token attributes. So as I mentioned, Spacy works with a pipeline object. And the main idea here is that there's an NLP function that we're going to create from Spacy that is going to automatically take in raw text and perform a series of operations that is going to tag, parse, and describe the text data. And those operations are known as tokenization, parsing, part of speech recognition, and so on. And we're going to cover each of those in a lot more detail later on. So what our purpose for this lecture is to discover the pipeline object and various series of operations. In subsequent lectures, we're going to dive a lot deeper into each of these individual aspects of NLP and Spacy. So we're going to talk about tokenization, parts of speech or POS, stemming, lemmatization in a lot more detail. So keep in mind, we're going to introduce those terms right now in this lecture, but we're going to dive into a lot more greater detail later on. Okay, let's get started by opening up a Jupyter notebook. Okay, here I am at what is essentially the repo for the course. Underneath NLP Python Basics, the very first notebook is called Spacy Basics. That's the notebook we're going to be going over in this lecture. I highly encourage you to also check out that notebook on your own. There's lots of useful information, including installation and setup information that we covered in the Spacy setup lecture, but there's also tables, so if you start scrolling down, you'll eventually find tables that talk a little bit more about tokens and tokenization. So definitely take a look at this as we go along here. I'm going to open up a new notebook, just create a new untitled notebook here. And what we're going to do is essentially go along with that lecture. So let's get started. The first thing we need to do is actually import Spacy. So we'll say import Spacy, and then we're going to load the language library. We will say NLP is equal to spacy.load, and then we're going to pass in a specific string, en_core, which stands for core English language, and then web_sm, which is essentially the small version of this language library. And then we're going to hit enter here. And don't worry if this takes a long time to load. The very first time you run it, it takes a while. It's a fairly large library, but it's also part of what makes Spacy so efficient, is that a lot of what it's running on top of is preloaded into this library. Then the next step, what we're going to do is create a doc object or a document object. So we'll create a variable called doc, and we're going to pass in a Unicode string. That means we preface that string with a U, and we're just going to pass in a string that says Tesla is looking at buying US startup for $6 million. Okay, so what's actually going to happen here is using the language library that we just loaded, that Spacy developed, it's going to essentially parse this entire string into separate components for us. And it's going to parse it into what are known as tokens. Essentially, each of these little words is going to become a token. So what I can do is say for token in doc. So I can actually iterate through this document object. And then I can print out the token, and there's various attributes I can actually grab from each token. So for example, I can grab the token text. And the token text is actually the raw text that it grabbed. Notice that it's smart enough to actually treat u.s. these capital U and S as a single token. Spacy, through a lot of development, is actually smart enough to realize that when we say something like capital U dot capital S dot, we're talking about the country US. It's also smart enough to realize that this $sign and the 6 should probably be separated. The $sign stands for US dollars, and the 6 stands for an amount, and then million stands for another amount. And later on we'll see that with named entity recognition, Spacy can actually tell things like Tesla as being part of a company. So what we're going to do here is say print token.txt, and then we're also going to print out some more stuff. Let's go ahead and print out token.pos, which stands for part of speech. So when we run that, we now see this 95, 99, 99. And later on, we're going to see that each of these numbers actually corresponds with a part of speech, like an adverb, a noun, a conjugation, etc. If you actually want the raw name, you just need to say POS underscore, run that, and it will tell you what part of speech it is. So notice it's smart enough to know that Tesla is a proper noun. Is a verb, looking is a verb, proper noun for US, startup is a noun, and so on. It's also smart enough to realize that million here is a number, and so is 6. And then this $sign is a symbol. So already right off the bat, Spacy knows a lot of information about each of these tokens. And then you can also do things like print token dot, and if you do DEP underscore, it's going to give you even more information. And DEP stands for syntactic dependency. And we'll talk about that in more detail when we talk about specific tokens. But hopefully now you can see that it's really incredible the capabilities of Spacy along with natural language processing to grab a lot of information just from a simple string. It recognized that Tesla is a proper noun, not just a word at the start of a sentence. So Tesla here is capitalized not just because it's the start of a sentence, but also because it's a proper noun. And it was able to tell that. It's also understood that US, these dots don't separate it, it's a single entity, it's a single token. And as we dive deeper into Spacy, we're going to see what each of these abbreviations mean and how they're derived. We'll also see how Spacy can interpret the last 3 tokens combined to 6 million, that $sign, that's 6 million. It's going to be able to understand that all of this is some sort of quantifier of money. But let's go ahead and move on and discuss the pipeline object. So after importing the Spacy module in the cell above, we loaded a model and named it NLP. So this actual line of code is known as loading a model, and we called it NLP. Next, we created a doc or document object by applying this model, NLP, to our text. Spacy also builds a companion vocab object for vocabulary, and we'll cover that in later lectures. This doc object that we created holds the processed text, and that's really the focus of this lecture. So off of this NLP object, what we can do is call dot pipeline. So when we run NLP, our text is entering a processing pipeline that first breaks down the text and then performs that series of operations of tagging, parsing, and describing that data. So we can see here the basic NLP pipeline is a tagger, a parser, and then NER, which stands for Named Entity Recognizer. And we'll talk about each of these in a lot more detail later on. And you can also just get the basic names by saying NLP.pipe_names. And you can play around with the various attributes here, which we're going to talk about as we continue on throughout the course. The first one I want to discuss just quickly is tokenization. So the very first step in processing any text is to split up all the component parts, that is the words and punctuation, into tokens. And these tokens are annotated inside the doc object to contain descriptive information. So let's go ahead and see an example. I'm going to create another document, doc2, and we're going to pass in a Unicode string, means it starts with a U, and we'll say Tesla isn't looking into startups anymore. We run that, and then let's go ahead and print out the tokens. For token in doc2, and we're going to print, let's go ahead and print out the same information we printed out last time, which was the text, the part of speech, and then the syntactic dependency. So if you run that, you can see again, Tesla, it's a proper noun, the noun subject, and then it's actually able to understand that is and N''T is actually a conjunction. And it's going to be able to keep them separate as well as know the relationship between these two parts of these tokens. So it's really advanced what Spacy is doing here. So again, notice that isn't, it really actually, it's been split into 2 tokens, and Spacy recognizes both the root verb is and the negation attached to it. So it understands that is the root verb and that this is a negation, this N''T. Notice also that both the extended white space and the period at the end of the sentence are assigned their own tokens. So if I were to put in a lot of extended white space here and run this again, this space would actually become a token with Spacy, and then this dot is a punctuation. Now I want to point out that here we're iterating for every token inside of this document object, but we can also use indexing to actually grab tokens individually. So if I take my document object, I can use indexing to grab the very first token off of this, and by default it returns that token text. But just as before, off of that token object, I can ask for attributes like part of speech, and it returns back prop n, which stands for proper noun. And if you check out our Spacy Basics notebook and scroll to the section we're at right now, which is learning about parts of speech tagging, dependencies, additional token attributes, and so on, we have a couple of useful links here for understanding the different annotations. So here we saw that there's a part of speech like prop n for proper noun, verb, space, noun, and so on. You can check out the link in the notebook that we provide here for annotation specific, and there's also a variety of languages here, English, German, etc. You can just expand English, and it'll tell you the part of speech, the morphology, and the description. So you can take a look at all of this to see what all of this stands for. So if you see PRON, that stands for a pronoun, personal, and then so on, you can keep going on in more detail. And it does this for a wide variety of languages. So there's parts of speech tagging that's available to us, and we'll cover parts of speech in a lot more detail later on its own. There's also syntactic dependencies for each token, and that, as I mentioned, is just going to be the call. For example, if we grab the first item here, we can say DEP underscore. This is the syntactic dependency. Again, there's a link inside the Spacy notebooks. You can go here, dependencies, get a full list of syntactic dependencies. So right now, those are only available for English and German. So you can expand English and see the label as well as the description. We've also provided inside our Spacy Basics notebook a good explanation of what these dependencies actually stand for. Again, this has more to do with a really good understanding of the way the English language works, which can be really complicated at times, but this isn't really an English course, so we're not going to dive too much into the details, but this link here that we provide for you is a full paper explaining the various dependencies and what they stand for. Things like a clausal subject, a dependent, a clausal passive subject, and so on. This sort of level of detail is sometimes really important if you're trying to build a chatbot that can understand things like present versus past tense and so on. Keep in mind, Spacy is doing all this work for us under the hood. So we'll come back to our untitled notebook, and the last thing I want to mention is that there's lots of other additional token attributes. So far we've seen parts of speech, dependencies, and a couple of more. If you come back to the Spacy Basics notebook and scroll down, here we have an entire list of the different tags and the description. So for example, if we call .text, that's just the original word text, which in this case would be Tesla. If you want the lemma, that's going to give you the lemmatization or the base form of the word. And later on, we're going to talk about lemmatization in a lot more detail. Notice here that essentially the result is just lowercasing this. There's the part of speech, a simple part of speech tag. If you do .tag underscore, it actually gives you a detailed part of speech tag. So beyond just proper noun, it'll tell you proper singular. So it understands that Tesla is actually a singular object. Then you can ask for the shape, so things like capitalization, punctuation, digits. So the way it shows that is it shows a capital X, so indicating that the first letter was capitalized, and then lowercase x for everything else being lowercase. And you can also ask, is alpha or is stop? So is alpha answers the question, is the token an alpha character? So it is alphanumeric. It's actually just an alphabetical character, excuse me. And then is stop asks you, is the token part of the stop list? So one of the most common words of whatever language you're working with. So Tesla is definitely not one of the most common words in the English language, so it's false. So you have all these variety of tags that you can call off of any of these tokens, and Spacy did this all automatically for us the very minute that we passed it into this NLP. And again, it's doing this all based off the fact that we loaded in this library, which is why it took some time, but that's what makes Spacy so efficient. It loads up this library first for us. Now, large doc objects can be hard to work with sometimes. A span is a slice of a doc object in the form some start versus a stop. So I'm going to copy and paste, because it's quite a large string. If we scroll down here to spans, and I'm going to copy and paste this cell. That way we don't need to write it all again. And essentially, we're just passing in a really long string. So, although commonly attributed to John Lennon from his song Beautiful Boy, and so on. So I have this really large document, and what I may want to do is actually just grab a span of it. So I can say life quote. So notice here, there's a quote here. Life is what happens to us while we are busy making other plans. And what we're going to say is life quote is equal to doc3, and starting at index 16 up to but not including index 30. And then I can print out the life quote, and it gives me this quote. Life is what happens to us while we're making other plans. So this is now a span of that overall document, because this document is quite large, and maybe we were only interested in this particular quote inside of that document. So what's really interesting is that even though we're only grabbing a section of this document, Spacy is smart enough to know that this life quote is a span. So if you check out the type of this life quote, Spacy is doing a lot of work under the hood to understand that this is a particular span. Unlike the entire document, which is we check type of doc3, it understands that that's the entire document. So when you take a slice out of this, Spacy is going to be smart enough to understand that it's the span of a larger document. And then certain tokens inside a document or doc object may also receive a start of sentence tag. While this doesn't immediately build a list of sentences, these tags enable the generation of sentence segments through doc.sents. And later we're going to write our own segmentation rules. But let me just show you a simple example. We'll say doc4 is equal to NLP, create a Unicode string, and say this is the first sentence, period, space. This is another sentence, period, space. This is the last sentence. So here we have 3 sentences inside our document. And again, Spacy doing a lot of work for us. It actually understands and is going to separate each of these sentences throughout the documents. So I can say for sentence in doc4, and if I just said doc4, that would go through every token, but I can call the sents or sense attribute in order to print out each particular sentence. So Spacy automatically understands that this period and this space is a sentence. And then I can say something like doc4 at index position 6. So that's this right here. That's this word right here, this. Remember, these are tokens. So we have various tokens here. I can call dot is underscore sent underscore start, asking, is this the start of a sentence? And if you run that, it'll return true. If I check it out for another token, let's go ahead and check it out for token 7. That's this is right here. Let's actually make it more obvious by token 8, the word another. I'm going to ask, hey, is this word another the start of a sentence? And if you run this, it's not going to return anything. It's going to return none because it is not the start of a sentence. Unlike when we passed in 6, it returns back true. So it's really incredible the capabilities of Spacy to take in a raw string and completely understand things like parts of speech, name entity recognition, token attributes, where a sentence starts and ends, and a lot more. So we just touched the tip of the iceberg, but really I hope this gets you excited about the potential capabilities of Spacy. Coming up next, we're going to dive in a lot more detail to each of these particular components. I'll see you at the next lecture.